Thank you. Thank you for being here. Well, I always try to start my presentations trying to impact you. So I'm going to use this $2 trillion that is basically the cost of poor quality code just only in the United States in 2022. But if you tell me, okay, I'm not concerned about money, it's not on my focus, it's about 4 days per month and developer that we spend on fixing errors. Now that I hope I have your attention, let me introduce this presentation. It's about clean code, and I will try to convince you that it's really worth it. But let me do it following a story of monsters, heroes, and finally a victory. This is me. I'm Jonathan. I'm Java champion and also one of the leaders of the Barcelona Java community and co-founder of JVCN and DevVCN Conf. If you haven't heard of it, please check it out because it's a great conference too. I've been developer for more than 30 years using several languages, but I would say that one of the most loved ones was Delphi. Has anybody here used Delphi before? Yeah. But I also work as a developer advocate for Sonar. If you want to know more about me, just simply scan this QR code. And what is Sonar? Have anybody of you has heard of it before? Sonar. And which of you have been using Sonar? Great. So for the rest, Sonar is the company that provides tools and methodologies for following the clean code approach. And we have like 3 different tools, free, the 3 of them. SonarLint, it's a plugin in the IDE that will help you to be clean as you code. SonarCube, that is going to check as a quality gate your code. And SonarCloud, that is also similar to SonarCube, but hosted. SonarCloud is free for all open source projects. Apache Foundation, Eclipse Linux Foundation, and Quarkus are using it. But also SonarCube is free on the community edition, and you can download it. If you want to know more, just ping me afterwards or go to checkandsonarsource.com. So let's go deep into the presentation. Here you have the QR code for the slides, so if you want to check them out as I'm talking, go for it. So the agenda for today is, okay, I'm going to define what is clean code. The cost of it, I already introduced a big number, but let's go deeper on that. And the definition of the contrary, what is clean code? I will show you some telemetry about the most detected issues that I think it will surprise you a bit. Also some interesting hints if you want to code clean, and some of the toolings that you can use in order to follow the clean code. And is here anybody following the Mandalorian TV series? Okay, so for all of you, this is the way to follow clean code. And finally, some references if you want to check more about this topic. So let me introduce you which is the monster of this story. It's Porky. This is the monster of the poor quality code. It's a hydra with 3 heads, but it could be more heads. This is a project that at least I have been in the past several times. So probably you can find one of the projects that you are contributing to that can follow some of these properties. It's buggy, so it has lots of bugs sometimes, and it's hard to fix them. High coupling, because you have classes that are depending on a lot of classes, and it's hard to develop a new feature without touching the rest. Low cohesion, because you have domain objects scattered across the code. And also you are using obsolete or old libraries. Having, well, not updated libraries means CVEs not fixed, performance issues not fixed, so, and new features, obviously. It costs a lot to refactor this code in order to fix issues or in order to improve or create new features. But there are more things about this poor code. It can have a lot of CVEs because you are using all libraries, because you are not checking the security of your code. So you can be introducing CVEs, so having low security. But also it can lead to have Memory leaks, because your methods or your classes are doing too much. You are having brain methods that probably you are not releasing resources when it has to be released, and it can lead to have memory leaks. And low throughput, because your methods are doing way too much things that are needed. Non-deterministic results, because you have, again, big things, object domains scattered across the code, and it's hard to replicate all the workflows of your code. So it can be that some use cases or workflows are not covered or are not expected. Again, use cases not covered, and it's hard to test because it's hard to replicate those tests. So it can be that you are covering the obvious, the happy paths, and some of the use cases that are easy to reproduce. But which is the cost of this poor quality code? Well, I introduced a number, more than 2 trillion. But just only focusing on finding and fixing bugs, it's more than 600 billions only in 2022 and only in United States. It's a lot of money. So now it's clear that the healthier the code is, the less number of bugs it will have. Therefore, the less money we are going to invest on fixing them. You can check the report down here when you go to the slides, and you will have more information about all the costs about poor quality code. But not everything is lost. So we have a hero in this story. It's called Clean. But basically, it's you. How many developers are here? Okay. So it's you, all of you, who are the hero of this story. And what you or Clean does in a regular day, probably you can find here. Well, introduces new features. Yes, that's why we are paid for, right? Fixes some bugs. Well, I haven't followed this approach. I was never that happy, but I know it can happen. But it has little time to tech debt fixing. How many of you think you have enough time to fix tech debt? Perfect. Who thinks you have medium time to fix tech debt? And finally, who thinks you don't have enough time at all to fix tech debt? Okay, so it's more aligned to not having enough time. But also studies new technologies. This is a very interesting point, and goes to meetups and conferences. Now I'm here, I'm passionate about this. Going to meetups and conferences is the best thing professionally that has happened to me ever. I have a life before and a complete different life after. And you should be proud to be here. Not everyone is in a meetup or in a conference. So you should be very happy and continue doing it. It's the best thing that you can do. But also, for sure, you rant about all code. Just up to the point that you discover that it was you who introduced that code. But we usually do that. And which are the goals for you and for the software? Well, basically, our hero learns or knows that there is a clean code warrior order with some principles. And our hero joins this order. And these are the principles of the clean code. Basically, it has to be consistent across all your modules or your code, using the same approaches and the same methodologies for fixing the same issue. Adaptable, because you need to follow a modular approach in order to improve new parts without touching the rest. Intentional, because it needs to be clear what you are doing. So sometimes we take a look to a code and we don't see clearly what it is doing. We need to read a lot in order to understand. So this is also a very important part. It needs to be very, very clear what it is doing. And finally, responsible, because it needs to, well, first, don't break any law, copyrights and everything, but also to use an inclusive language across the code. And just talking about, that was about the software goals. But what about our goals? So it's not only about software, it's about us too. It's important that we are confident with the code that we are committing. not just being nervous, just waiting for the, I don't know, the quality gate analysis to run and says that we have introduced several bugs or several issues. Also, we need to be proud that we are committing the best code that we can. We need to know that we are submitting good code. And finally, we need to be skilled. So we don't want a tool that it is simply complaining when we submit bad code, but we want to learn about this code and to be a better developer every day. So our hero, Clean, wants to know first how it is the market, how it is the city about the Porky attacks before just going out and fighting the monster. And just following the Sonarlink telemetry that we get from all the plugins that are running in the world, covering more than 1,800 million of issues detected. Only the top 10 are 565 million issues. So we are having this telemetry report with lots of data. And the most detected issues are the cognitive complexity is too high, so our methods are hard to understand. Then we have a lot of unused or dead code. Local variables not used, function parameters not used, private fields not used, private methods not used, imports not used, that's common. And also a lot of commented out code that we don't know if commenting it out was the right thing or we should uncomment the code because the right thing is that the code exists. Also a lot of to-do tags. I have an example of one Apache project that after 10 years, they still have a to-do in the code. So 10 years of a to-do line in the code. Raw types used in Java, we have collections, and we should specify which is the type of the collection. Java developers in the audience? OK. And we have string literals duplicated. We should use constants and not just replicate strings across the code. It's going to be easier when we need to implement new features. And also generic exceptions. In Java, it's like raising a new exception that the consumer doesn't know exactly what to do with that exception. We need to use specific ones. And reference to null, because we are not checking if a variable can be null, we are using it, and then in runtime, boom, null pointer exception. So if we group them, it's like having complexity, dead and useless code, comments, design, error handling, and null handling. But there are also most detected issues regarding security. Secure password should be used. So we are not using the right algorithms to create passwords or to use them. We can have XML execution inside our parsers. So we should check about that. Endpoints vulnerable to cross-scripting. So also we should check about that. Credentials hard-coded. Do you think this is rare or weird? No, 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 it's not at all. It's common, very common. So obviously, we should not have credentials hard-coded. But the important point here is that we all agree that this is bad. We all know that we should not hard-code credentials. But some are slipped into our code. So we need something that checks our code and tells us that there is something wrong. And function calls to the input-output system using external values that can be vulnerable to path injection attacks. So basically, credentials and scripting or injection. Basically, this is the summary of the situation out there. A lot of dead code, complexity, comments, error handling, design, null handling, and vulnerabilities. But our hero needs some tricks, some hints in order to fight Porky. So she goes to train and to receive some classes. And let's see some vulnerabilities and security changes. I don't know if this is real or someday I will try this and see what happens with the SQL injection in the traffic system. Okay, credentials should not be hard-coded, obvious. just use a third-party system in order to store credentials, not hard code them. Database operations should not be vulnerable to injection attacks. Do not use a string concatenation. In the world of Java, use prepare statements and parameters. That way, you are avoiding most of the SQL injections. Persistence entities, well, I have a special opinion about this. I don't like using persistent objects coming from Hibernate or any other ORM frameworks up to the REST APIs. I prefer DTO, the DTO pattern instead of using this other approach. Why? Because if we are using the persistent object up to the REST endpoint, then we can receive values in the fields that we don't want, and they are going to be persisted. So one way is to use DTOs with only the information that is going to go to the customer, well, to the client, and that we are able to process, or sanitize the object when you receive it. But basically, going to the DTO pattern will solve this. But there are some bugs and code smells too. For instance, for those that are using a Spring framework, this framework scans beans coming from the package where the Spring Boot application is defined, or the package defined in the annotation component scan. If you don't specify none of them, the Spring is going to scan the whole class path. Therefore, other jars or even the same Spring source code. So this is not the good approach. When you are having multi-threading and for any reason you need to sleep a thread, do not use sleep. Use wait, because it's going to release the lock, and you can use the lock in other threads. This is very obvious. Test should include assertions. But the problem with this is that if you create a test without an assertion, it's green. Fine. Nobody will notice if you haven't added a test or assertion in your code. So you need someone that checks the code for you and complains if you miss that. Resources should be closed. Sometimes we are using resources and we need to free the memory manually, releasing it. Well, in Java, use try with resources and it will be automatically released and you don't have to wait for the garbage collector. With design and complexity, these two methods have the same cyclomatic complexity. But at least for me, it's clear that the left one is way harder to understand than the right part. But they are having the same cyclomatic complexity. So in order to fix that, what we are going to use is cognitive complexity. It's a different calculation. And now we have the left part with a cognitive complexity of 9 and the right part with a cognitive complexity of 1. Then it's clear that you need to refactor the left part in order to understand it. So you need a tool that also calculates the complexity for you. Methods should not perform too many tasks. This is called the brain method. So just split it in smaller methods that you will be able to test separately. For Java-specific versions, in the Java 12, we have the switch expression that makes having a switch way clearer because you don't have intermediate assignments, and also, well, it's basically you get rid of the breaks. With the streams, before this, Java 16, we needed to collect them and use the to-unmodifiable list in order to return an immutable list. Now with the stream to list, we are collecting the result into an immutable list and returning it. It's way more clear and consistent. Also, records from Java 16 should be used instead of having plain Java objects, and then those are immutable and way clearer. With hash-based collections, in Java 19, it's basically when you create a new hash map, you are going to use the default constructor, and it's not ensured that the system will provide that amount of memory at that moment. So it's gonna get memory in bunches. So just use the static method, new hash map, and you will have the whole memory at that moment. So in summary, it's a lot of things to have in mind, plus your internal rules. And you need to do it every time that you code, every time that you commit, every time that you review someone else's code. So do we have any weapons? Yes, our hero have static analysis tools like linters, like PMD, SonarLint, CheckStyle, or others that will check our code as we code. Also, checking for bugs and vulnerabilities. So one of the linters, in this case SonarLint, is going to complain with a hint in your issue. You are going to get the list of issues and also a long explanation of the issue with why is this an issue and the way to fix it. So this is an important also to learn and to improve. And also quality gates that are going to be connected to the CI/CD pipeline that will check your code and will prevent bad code to be merged. So we have three different focuses. One is clean as you code. So you use the linter and your IDE and you see the issues. You will learn about this because you check the documentation of each rule. So you will learn from your issues. And also for team retrospectives in order to get more information about every of the issues that you that the tool detected. But at this point, our hero needs a path, a way to do this. How I can try to handle clean code? Well, basically, using clean as you code approach. So it's not focusing about old fires, but just focusing only on new code. Why? Because code, as everything living in this world, dies. So basically, every year, 20% of the code is modified. So just following this example, we see the code that was introduced in 2010, in 2022, is no longer there. So there's no point on putting effort on fixing old code because this code will eventually die. So just focus on new code. Some of the tools, SonarQube, for instance, has a tab for overall code and a tab for new code. And then you will only need to focus on new code because eventually, after a few years, your whole code will be clean. So at this point, we are finishing. There are two ways of killing Porky. So basically, remove all issues in your project today or chop ahead, but very often. Who thinks the right approach is killing the monster today? And who thinks the other is the right option? And the rest are shy. Okay, so yes, it's clean as you walk. You just only focus on new code, and you will eventually have clean code. Conclusions. So basically, clean code, not having clean code will impact not only on your software, but on reputation and morale of the team. And developers do not have enough time to invest on fixing tech debt. And clean code will impact not only on software, but also on the developer perception and morale. But there are hundreds of issues and things to consider. Just only for Java, Sonar has more than 600 rules. So it's a lot to have in mind. So we need some tooling. So there are several tools. Obviously, there are tools from Sonar, but there are tools from others. Just check them and use them. Only a portion of the code will survive, and there's no point on focusing on old code. Just focus on new code. And also that AI tools can be helpful, especially for designing images for presentations, where you can find people with 6 fingers or 3 legs. You have here some references if you want to explore more about all this topic. That's been all. Here are the characters used in the presentation. And basically, that's it. Please, please, please use the QR to rate my presentation. I will learn a lot from it. And if you want to check the slides, this is the QR too. And for SonarLint, if you want to try it, that's the link to use it. That's all. Thank you very much.